Well, it looks like it's a topic of interest across different groups and different interests, different scientific interests. So I think there's nobody else coming in. So go ahead and introduce us.
Good morning to everybody. Thanks for coming to this talk so early in the morning. I wanted to tell you, we thought it was interesting to present to the institute and the department this new tool that some of us here have been working on. We call it Denario. Pedro will be as part of the presentation. I have been involved myself in this effort. We call this Denario. It's a deep knowledge agent for scientific discovery. You will see when Pablo explains to you the purpose of the tool is actually to have a multi-agent system that does automatization and automation, if you're American, and then looks into the literature. It does calculations, produces Python code, plots, and a paper. So you have an idea, you can actually go there and do it. So I'm going to do a paper for you online, live, as we are here. Let me just exit the presentation. Let me, okay, now I have to do a bit of, I'm going to ask the system the following, which is something I will read it for you. Analyze the Horndeski Lagrangian, so modify gravity, okay? As described here in this review paper by one of our postdocs, Emilio Bellini. The goal is to investigate whether hidden symmetries exist that can protect the theory from instability such as ghosts, tachyons, or other undesirable features. One of the big problems of these extended Lagrangians is that they have all this kind of sickness. The analysis must show explicitly that no ghosts are generated, not even at first-order perturbative corrections, one loop level. Additionally, any proposed symmetry should be compatible with observational constraints, such as the speed of gravitational waves constraint is the same as the speed of light, consistent with expansion and extraction. Do a thorough analysis and write a detailed paper, okay? So I woke up one morning, I want to do that. Of course, you can do a million things, like here. So let's put it to run. Okay, it will start running. At the end of the talk, we can go and look at the paper. Exactly. Very good. Okay, now let me just go back to the original setup. Okay, here we are. Okay, now we call this system Denario, inspired by the old Romans because it was a standard silver coin, but especially it gave consistent value, making it a reliable medium for doing everything you had to do in the Roman Empire. Okay, scan the code if you want to go to Denario, to the website. Pedro will explain what it is, or just click on the link. Now, has been an effort from many people, okay? But I like to highlight that it's almost a Spanish-dominated effort, right? Two of the three main PIs, Pablo, Paco, and Boris are Spanish. And many of us are also like that. Did you include also our Latin American colleagues? It's a very Spanish-dominated collaboration. Many institutions, very distinguished ones, especially I want to highlight the Salmon Foundation, but we also have worked with private enterprises to actually make this effort work. So I will stop here. Licia is going to introduce the setting, the problem, and the possible advantages of this. So the floor is yours, Licia.
So I'm going to say something obvious, but keep that in mind as we go on with the presentation. So how does our current system for scientific dissemination and publishing works? Well, you do research and produce a paper, and this takes you months or years, as the PhD students that are here know. It's a very labor-intensive work to produce a paper. Then you put it in archive, and then it becomes distributed to the entire world in a matter of hours or days, if you are working through a weekend or a vacation. Usually to have validity for our CVs, archive is not enough. It needs to go to a journal. And in the journal, you have a whole series of layers and people that work on your paper. You have editors that decide whether the paper subject is worth for the journal. You have editors that decide referees, and the referee goes with a fine-tooth comb through the papers and understand whether it is correct, what value is added to the field, etc. Then there is a quality assurance check for copyright, for plagiarism, for references, for figures, for languages, and that. And there is the whole thing about curation and cross-linking the references and accounting for the citations and so on and so forth. And this goes into a big bucket that is the scholarly record of knowledge, which is supposed to be something that is pristine, that is new, and every time you add something, it adds signal and it doesn't add noise. And you can find it and so on and so forth. And everything you add is actually new. It's of interest. Otherwise, you would have a very low signal to noise, big bucket of stuff. And so and the researcher discovers new ideas, either by looking at the immediate things that come out through the archive that hasn't gone through the peer review, has gone only through some very lightweight moderation, and through the full search.
Is it clear that there is no noise? How do you find that there is?
Well, I just said that there should be no noise. That's the idea.
Okay, so
That's the idea. That's the definition. Exactly. Yeah. You hit the nail on the head. Yes. You hit the nail on the head. So all this works because the effort of scientists, editors, and referee are the same community as the one that actually produced the papers. The effort the scientists put on this needs to be epsilon compared to the effort that we put on that. Otherwise, the whole system doesn't work. The whole system can crash it down. And the content must be of high value, of interest and added value. So when I say high signal to noise, that's what I mean. The whole system works based on these assumptions. Sometimes they may be violated, but on average, that's what makes the system work. And I want to introduce an existential question, sort of. What is a scientific paper? The modern concept of a scientific paper emerged with the Royal Society of London in its journal Transaction in 1665. The world back then was very different. The figures in the paper were drawn by hand. This was your typical editor, and this was how the paper would look like. The world has changed a lot. Yet the scientific paper has not changed so much. We still use the same kind of thing to distribute our science and our knowledge. Before that, the scientific discoveries were published in pamphlets or in books. But the pace of science has changed quite a lot. So now with this in mind and with this background, let's go into the meat of the talk. So I gave you some initial philosophical overview. The next part of philosophical overview will come later. Large language model and AI agents, what Denario does, what Denario will produce in the time that we are here in this seminar, and then finally some ethical consideration and where does this leave us. So
thank you. So for those of you that arrived late, at the beginning of the talk, I asked Denario to produce a paper on modified gravity. I asked it to analyze the Fornensky Lagrangian and look for hidden symmetries that make sure that there are no ghost tachyons or anything like that, taking into account that this symmetry should be also be preserved at one-loop theory. So he's working on that. He will produce a paper by the end of the talk. What? Sorry?
Wood paper?
Well, that's
the question and answer at the end.
that
For this not paper is easy.
it will be produce a paper that has calculations and reproducible results.
Paper.
It will produce a code and it will produce
Yeah, you are an editor, so you choose. So
logical scheme that
Oh.
but it's a very good introduction to what I was going to discuss, because there has always been a skepticism about technology helping knowledge. So this goes back to the Greeks, right? And probably the smartest people that have been on earth. You Greek, I highly recommend you read Aristotle and Plato, the original ones. You will be amazed about the capacity of logic that these guys had. But of course, these guys were outraged that suddenly the written form of knowledge was going to play a role. Because for them, the only way to actually progress knowledge was talking to each other. And in fact, when Raphael depicts the famous painting of the Athens school, nobody's reading anything, people are talking, right? So the main role was to talk. So we are talking about 2,500 years ago, circa, that people were already in a state of shock about what technology was going to bring to knowledge, right? Now, could you imagine a world without written text these days? Now, this kept evolving, you know. Of course, the next step is when the print goes into action, right? And then there's a huge upheaval. It's actually this painting is based on true facts. When one of the Gutenberg prints was attacked by a mob because they thought it was a source of propaganda, it would undermine true intellectual pursuits by creating too many low-quality books. Okay? We're talking, you know, low-quality papers. Here we are, you know. Scribes even attacked a printing press in 1476, fearing the new technology would threaten their livelihoods and status as knowledge custodians. You know, especially this misinformation and propaganda was a big issue about the problem there, you know. So the capacity of producing books, we are now at the stage that we have moved beyond that. Of course, the next step is computers, right? And the best mathematicians were outraged about the advent of the computer because it was going to completely destroy intuition.
I think you're building a strong argument. But go on.
Okay, go for it. Meaning?
What? Yeah, you're painting things in a very biased way. I don't think that the main mathematicians were outraged.
I think that's wrong, and I can demonstrate to you offline with the facts that you're wrong about what you're saying. But I don't want to go online now and look for it. But I can actually go online and afterwards and show. I can send you the.
Neumann was one of the mathematicians at the time.
Yes, and he was. And Turing as well was pushing for the computing, right? And before him, actually, his advisor in Princeton was pushing for that, but that was not the shared view among the classical mathematicians or the main bulk of mathematicians. Yes, sure, some mathematicians were pushing for this, but it's certainly not a factless statement, the one I'm making here, and I can give you the facts afterwards.
So maybe that's not really related to computing, non-computing. That happens with any theory. I don't know, when Einstein came, it was also against Newton.
It could be, but here I'm focusing on the role of technology in advancing science. What is the
culture? No, it's a new culture. It's difficult to accept.
That could be. I'm not entering that debate. What I'm saying here is that there is adverse cultural movement every time a new technology enters into the game.
But there's also many people who are in favor, and most people who matter. And I think that everybody in this room probably is in favor of using technology to advance it.
Okay, that's very good news to hear, because that's not the case. I have been giving talks at MIT. I was, of your view, super happy about Denario, like extremely excited. I gave the same talk at NYU, and I wasn't assassinated because I'm a big guy. Otherwise, I'd be like killed to death there. But they were scared, right, that they were going to attack me. So yes, most people that are doing top research, that's the case. But some places, you know, they see this as a huge producer of garbage. Okay.
It can be both things.
Of course, like it has been with.
So don't cherry pick and don't build strong arguments.
I disagree strongly with you. Okay. I do want to, since of course the ones of you that arrived late didn't see the introduction, that this Denario is a Spanish-led, Spanish speaker-led effort. I wanted to highlight about the actual father of AI. Goes back to one of our countrymen, or some of us, our countrymen. That actually is Torres Quevedo, that actually built one of these automated systems. Because this ajedrecista, this chess maker, actually, it is based on autonomous decision. It's a very simple thing, you know, king and rook versus king, right? It's a very simple thing, but it's actually autonomous based on relays. So sometimes we just jump to 1960 and credit the Americans about that. It was actually a future for him. Now things move forward, of course. Now suddenly you have what we call query-based information, right? In the sense that we are no longer going to libraries and looking at books, right? We basically query the system. These are two examples. I chose them because Professor Verde is the chair of the advisory panels on both of these efforts, right? It's like a world domination. But for us, for astrophysicists, of course, ADS is the main source, and we don't use that very low-class web server that you call Happy Spire. Nobody has heard about it. And of course, the archive is the main repository where we collect the preprints, right? So, okay, this was another revolution, right? Now you could be in a very low-key third-world university, like the University of Barcelona, and look at the preprints that the people in Princeton would get in the time of paper, hard copies. They will get them there in one day. Here it will take months. So by the time you were reading the preprint, right, it was already late. People had already worked out what Professor Witten was saying. And then you were completely late. So at that point, you know, before the 90s, it was really crucial to be at the top place because you wouldn't get information. Archive democratized that effort. It just made it trivial for anybody. Wake up in the morning with an internet connection and see what people were doing in the world. And it completely changed the face of how research was done. It really opened up the thing. Well, so we want to, yes, sir.
But do you think, for example, that made it more independent? In the sense that the fact that there is no time, but actually they have been discussing before writing the paper, they have been discussing it, in Princeton, and they are actually much more advanced. And the fact that now people have the illusion that the paper is coming at the same time, because it's an illusion, basically makes every people being researching about what some people are doing, and then they don't have a chance of competition. Still, and actually the state universities basically dominate the whole world in positions, and people have no research.
That's an interesting point.
It's not clear.
That's an interesting point, and a different issue, right? Here is the question is, even though the information is available to everybody, do you still do the best research if you get 5,000 euros from the University of Barcelona to do your research, or you get $50 million? I mean, you know, this. I show you my funders, right? The Simons Foundation, right? You know, they provided millions to us, to my group, just to do research, right? Compared to, I think I have got €0 from the University of Barcelona in the last 10 years that I have been here.
No, you get.
Okay, maybe. So yes, I mean, your point is at the end of the day, you know, if you have a good funding situation, you can do better. But I think that having information democratized is a gigantic change. It's a transformational change in the way you can access science, because you can really actually see what is happening everywhere, right? Because the preprints go here, they don't go on the post, you know. Because you were not going to post to the whole world, you don't have money for that, right? You were going to post to a few places where you thought it was important to have these preprints, right? Okay, so the next step is going to be what we have done, and it is to actually take in a different level and ask the system to actually go and not only query-based research, but actually look at what is there in the whole body of knowledge, pose a question, plot the information, and do the calculation that you are telling it. It will produce code, it will produce reproducible results, plots, and that's what Pedro is going to talk about, because he has been very closely involved with Denario. So,
sorry, can I ask a question? Why is the target writing a paper and not like a summary or?
That's a super important question. That's a very important question. We can. What is a paper? I think Licia was.
So ADS already provides you that. You may not know it because it's not advertised. It will be advertised in these days. There is something called SciX. And then if you go there, it's plugged into a big large language model, and you can ask a question and it brings you back summarization. You say, take this paper and explain to me like I'm 12, take this subject and all the paper on this side. So you can do things like that.
Can do calculations as well?
But it will not do calculation,
Okay.
it will not do plot, it will not write down a report or something. However, I know, being in archive and being in the journal, that these kind of agents are already going on and are already polluting our literature. A lot of work is being done to stop them because they are low quality and low content. It's very easy to do an agent that does not very useful stuff, but it looks like a paper. An archive is in alarm because of that. You can break this. But this is different. This will probably fly under the radar of all the filters that are there. I know I tried.
I want to add one thing before Pedro starts, is that Denario is the first so far and only multi-agent system that actually does calculations. And we beat Google to that. Google has been trying to do that for years, and they haven't managed to do it. So yeah, we are porting the paper next week, and there will be a press release on that.
But to be honest, I'm not sure if you're selling this as a positive or as a negative.
That's for you to decide. That's for you to decide.
I
That's for
think
you to decide.
it could be either. What I'm saying is that the current system as it is set up, it's under threat because of this.
So as a negative.
The current system as it is set up.
It can be good that the current
It
system
can be
is
good.
better.
The current system is not.
Revolution are not always bad.
Exactly. But what I'm saying is that right now, if the moment this hits the market, we're gonna be flooded.
So this
By-
is modular instruction in short, this and say, okay, let's all be the same.
But this kind of standard.
It's a standard, but
There are tools already around that are doing this.
But
Exactly, but not that easy as.
but we can detect.
So you can go time to and asking things and not.
But there are dedicated tools.
Let's not underestimate scientists, right? I mean, who reads the archive these days, right? I mean, who reads the archive? I don't even look at the archive. I don't even care how many papers there are in the archive, right? So I think we are flooded with bullshit all the time. So by now we already know how to filter, right?
No.
So I'm not too.
We don't know how to filter.
Oh, okay. You don't develop a filter right now.
So how do you feel?
You will need to fine tune your filters, I
But
guess.
okay, so we know that
You feel?
we are subjects, right? We're subject driven, right? We have some area of expertise, many of us. We don't read across the aisle because it would be impossible, right? You agree or not? You don't agree? Okay, exactly. So within that, we know more or less what's happening because we listen to talks, because people come and visit. So there is the Greek.
But this is, you realize this is very dangerous, what you're saying.
No, that's fantastic. Wow.
It might work, but
Completely biased, no?
it can give you to a situation where you do what your friends are doing.
No.
Oh, yeah.
I don't do, I am the friend that
And I
does.
know several areas of physics.
No, I strongly.
Iterating and they are doing irrelevant things.
And they keep
And
deciding.
Okay, wait, but who decides what's relevant or not relevant? That's another question. Completely entirely different, right? But doing what your friends are doing is not always bad, right? It depends a lot on what you call friends, right? But the judgment by the society and the scientific community, whether it's good or bad, it's always been there. It's always going to be there. Unless this AI takes over, right? It will be us deciding how we move forward, right? And yeah, sorry.
I want to say one thing. Not all fields of science work in the same way.
Yeah.
People tend to think that all of science works the way that a field of science works. That's often not the case. And there are fields of science which are more easily flooded with garbage, and other fields which are much harder to clean.
You mean like
And that means I will. So if we're going to hear sweeping statements about all of science, not going to be too much. Different fields work in different ways. They will react differently to the introduction of nuclear technology. And that's
So-
what I think it's important.
So one of the things of Denario is that actually we have produced papers that go all the way from the clinical analysis to chemistry to material science to mathematical physics to astronomy, biology. The only place where we failed was mathematics. It doesn't produce, and this paper that we produced in the Denario paper, which is 300 pages long, was sent to refer it to experts, to human experts actually, to ask them, do you think this is a sensible paper? Do you think some of the papers were actually really good? And there were some of the papers said, okay, yeah, this is an average paper, doesn't add too much. But the other thing that we did was actually in the GitHub, there are all the efforts recorded, right? So we don't only show the nice papers, we show everything that we try to produce and where it failed and where it didn't. Go ahead.
Okay. So thank you very much, Raúl and Licia. Thank you everyone for being here. So most of you will probably know what this is, or this, or this. So these are large language models in which you can ask whatever you want and they will give you an answer. So these large language model or LLMs are a type of neural network or machine learning algorithm that are trained on huge base of data and can generate answers. So the goal of these LLMs is I can give a sentence to the LLM and it will give me the next word with certain probabilities, right? So for example, in this sentence, Barcelona is a city will be the most likely answer, but then it could give me different answers like great, beautiful, major, or for example, club. But how does this work? So let me go briefly on the main structure of these LLMs. So the first thing that we need is an input text that we want to be continued. For example, this sentence, the cat that chased the mouse was hungry. We will give this sentence to the LLM, and the first thing that it is going to do is what we call a tokenization. So a tokenization is an association between words and numbers. And we need this because words will be very inefficient and sentences will be very coarse-grained. So we need to make this relation between words and tokens. So for example, with this concrete algorithm, this sentence will be mapped to these tokens. The next thing that we want to do is map these numbers continuously into a high-dimensional space. This is what we call the embedding space. This is learned by a neural network generally, and we want the following features in the embedding space. The first thing is that words that are semantically related in the same way are also distanced the same way in this high-dimensional space. So for example, France or Paris, the angle between these two vectors is similar between Germany and Berlin because these words are related the same way, let's say. Another feature that we want in this embedding space is that words that have the same root are also placed together in this embedding space. For example, walk and walking. And the next thing is that words that are very different between each other are very far away from each other. So for example, in this example, cat and dog are close to each other, but banana is very far away from them. Now, the most important part of the LLMs and the reason why modern LLMs work are transformers. They were first introduced by these people in 2017 in a paper that is called All You Need Is Attention, because attention is a very important feature of this particular setup. This is, by the way, the most important paper in the modern machine learning community. So these transformers are composed by two main ingredients. The first one is called self-attention, and it is a mechanism in which each word will attend other words in the sentence. So a weight is associated, so each word will associate a weight to every other word in the sentence. So for example, in the example that I gave you, if we look at how the word was is attending the rest of the word, we'll see that cat is very attended in this way, but also hungry is very attended. So we can see here that the attention layer is discovering a grammar relationship between words. And the next ingredient will be the feed-forward layers. These are just neural networks in which these embeddings are passed through, and the final transformer will be just a concatenation of these two layers. And in this way, we can learn, for example, more deep relationships between words. For example, the first attention layers will learn grammar relationship between the words, but the very last layers will learn semantic relations. So for example, the first layer will learn this subject-verb relationship, but the very last layers will learn semantic relationship. Like for example, the relationship between climate change and politics, for example, or science. So the final step will be the prediction. So this is normally trained by knowing the next word, but we blind it to the model. So we will pass this sentence to the machine learning algorithm, and it will give me certain words with certain probability. So since I knew from the very beginning that the correct word in this sample was because, I can then compare the output of the model with the actual value that we know, and then I can optimize this and update the model in such a way that it gives me the correct word. So then this is trained on huge data, normally the whole internet and the archive and the Wikipedia and everything. And we will end up with an LLM that is properly, hopefully, working. So what we have done so far is we ask the LLM something, and then the LLM will give me an answer. So in this way, the LLM will perceive the environment in some sense because we are giving the LLM an input, and then it will take an action and it will produce an answer. So these are two of the main ingredients of what we call agents. The only one that we are missing is the decision making. So if we let the LLM talk to itself and make it decide whether the input is good or bad, we can add this feature, and then this is called an AI agent system because of these three properties. And if we add another LLM and one is talking to the other one, we do this thing that is called AI multi-agent system. So this AI multi-agent setup is basically characterized by different autonomous LLMs that have the following properties. They can perceive the environment, so we can give an input to the LLMs. They can also make a decision. They can talk between each other until certain task is done. And at the end of the day, they will give us some outputs. The good thing about this is that we can use different agents that are fine-tuned to do certain tasks. So we can use, for example, an agent that is specialized on making plots or making code, another agent that is specialized on making ideas, for example. And we can also change the relationship between the agents. For example, we can put different agents to have a meeting. We can put different agents as in a company-like a structure, so one of them being the boss, the other ones being some of them being the responsible of the business, the other one being the responsible of the code. And we can also use the agents in a plan and control way. That is the way in which it is implemented in Denario. So basically the main structure is this. We'll have some input. This is the multi-AI agent system. We'll pass the input to the different models that are composed by different agents, and they will give me some outputs. So just an example, I don't want to be like very broker here, but this is a very good and visual example that is trading agents that is in this paper. So in this particular setup, an AI multi-agent system was trained and was composed in such a way that they try to mimic trading strategies. So this was based on historical data, and you can see here in brown the agent's performance versus the standard algorithm that normally company uses to get benefits from trading, right? So you can see that the cumulative return is almost 30%, which is very good when compared with the usual algorithm. So now the next question is natural. Can we use these multi-AI agent systems to try to make science? So this is basically what the Denario project is trying to do, mainly, as Raúl said, developed by Francisco Villascusa, Boris Bollier, and Pablo Villanueva Domingo. And this Denario is an AI multi-agent system, which goal is to generate ideas, write a methodology, generate new results, plots, code, and put everything into a paper. So the final output will be a docx file that you can compile and generate the paper.
May I ask a silly question? Why the name? Denario?
So the name.
You missed the first.
Yeah, exactly.
Sorry, then don't spend that.
Okay, so it was because of Denario was the coin in the Roman Empire, so it was used to trade for. Okay, so
It's also because all the other names are taken. So there was a mostly practical explanation. Most of the names are taken.
okay, so Denario is built in a modular way using these two open source orchestration system of agents that are called AG2 and LangGraph. And it also uses a CMB agent, which is a particular plan and research, plan and control agent orchestration tool that was developed by Boris, Paco, and collaborators. So let me go straight with the pipeline. So this is the whole Denario pipeline, let's say. You will start with an input. That is the input that Raúl asked to the model. Write a paper about Hortensky gravity. So then this input will be passed to different modules, and each module will be responsible of doing some tasks. In general, this module will be composed by one or more AI agents. So at the end of the day, we will have all these outputs you can check, and the important one is this one, which is the paper. But in principle, you can call the system at whatever step you would like to generate an idea, generate methodology, results. Just it's very modular. So the first thing that we need to use is an input. This input will be passed to the idea module, and it must describe an idea that you want to explore, let's say, as the input that Raúl gave the model. Then we'll have the idea module. The idea module will receive the input, and it will try to generate an idea. So this module is made out of two different agents, and it tries to mimic the natural human way of trying to generate ideas, which is idea making and idea criticize. So one agent will propose several ideas to try to be novel, ideas that we want to explore in general, and the idea hater will criticize the ideas, will tell some of them are not feasible, some of them are stupid, some of them are not novel, and they will iterate until the idea maker finds the best possible idea from the given input. Then, one parallel thing that we need to check if this idea is novel or not. So we'll have the literature module that will search in the internet for different papers which are similar. And then this paper will be given to the novelty agent that will discern whether the idea is novel or not. This process will be repeated several times, and then they make a decision. The decision will generally be that your idea is novel or not novel. And at the end, it will give you a literature review with the most relevant papers and telling you why those papers are relevant and how are they related with the original idea that you gave. Then we follow the pipeline. The next thing, we have an idea, we need a methodology. We need to explore this idea. Then the methodology model will take both the input and the idea, and it will try to write a detailed methodology with every step that you need to follow in order to explore that idea. No results, just methodology, bullet points. Then this will be passed to the analysis module. This model will take input, idea, and methods, and the idea is the goal will be to generate new results and interpret those results. So the output will be, in general, plots and interpret the result in a report. So this is framed out in a research specialized agent, multi-agent system that is called CMB agent, which structure is this. Don't worry, it's very simple. So we'll have these research tasks, and these research tasks will be passed to the planner and plan reviewer. These are two AI agents that will talk between each other. The first one will propose a plan, and the reviewer will review the plan. They will start iterating between each other, until the plan is good enough. And then this plan will be passed to the control multi-agent system. There are a lot of agents here, but the most important ones are the engineer and the researcher. The engineer will read the plan and will write code and generate plots as they are described in the plan. So this guy is going to program everything, give you the code, and give you every plot. Then the plots and the results are passed to the researcher, and the researcher will make an interpretation of the plots and give you a report. Then the session will end, and the last thing that we need to do is write the paper. So to write the paper, we need everything that we have generated and put everything together into a single text file. How do we do it? Well, we have the following pipeline. We'll grab every input file and we'll give them to the following agents. So the most important part here will be the section agents, in which one agent will take care of writing each section, and the next section to the next. So the inputs of the, for example, this section, the method section, will use also the introduction and the abstract. So in this way, we can generate a paper that is not, let's say, that is well structured, right? Because these sections will use the previous knowledge of the other section. So then we'll have several tries to generate the paper. We will first generate a paper that is preliminary, and at the end, the citations and the final paper will be generated. This is just because if the process fails, for example, in this step, a human can take this paper and the citations by hand and compile it, and it is not lost. So this is basically the whole pipeline, and let me finish with some conclusions here. So we have used this setup that we call Denario, and we have observed that it is able to generate ideas, develop research plans, write methodologies, generate results, and put everything together in a paper. Also, in this point, it is crucial, validation is crucial. Why? Because making a scientific paper and something that looks like a scientific paper doesn't mean that you are actually writing a paper, right? So there are some fields, for example, abstract mathematics, in which you read the document, it looks like a paper, it is in paper format, and then you try to go to the results and are not good enough. It is just going around to the same idea, not doing something new, right? So in this way, we have a lot of advantages, and the first one is that you can call every module separately. So for example, imagine that you have some methodology or you have some results and you want to write the paper, you can give everything to Denario, and Denario will put everything together in a paper. This is in general a very tedious process, but you can just use everything and write the paper in person. Another advantage is that it is very replicable in the sense that every output, you can always analyze every output that Denario is giving to you. So for example, you can check the code, you can check if the code is well written, if the results make sense. You can also try to replicate the plots. And I would like also to remark that this is publicly available to everyone, but you will need the OpenAI API keys, which you have to pay for them. But these are only needed for the results module. So you can, in principle, run every other module separately. You will not be able to write a paper because you will need the results. But in principle, if you want to do a literature review, if you have an idea, you can do a literature review, just one click, and it will give you the most relevant paper. So yeah, that's everything from my part. I will now leave you with Raúl that will.
Thank you very much. Yeah, this is actually an important point because, of course, we have built Denario because the companies build the LLM models. This is something that is completely beyond the reach of any university researcher to actually run the required codes to actually pull out and build LLMs on this on the whole body of knowledge, right? It's only OpenAI, Google, and the other companies, Apple and Perplexity, that managed to do this. It's only within the reach of American government or the European Union, right? This is the amount of GPUs that you have spent on this is monumental, right? So this is something that sorry? Okay, so this is Chinese is I was going to do to that, right? So there are now some ideas about how to simplify these transformers. That's what Pedro was talking about, which actually related to something Pedro and Pablo developed called the multi-head approach to these neural networks. But this is something new, right? So whenever DeepSeek becomes lighter, even DeepSeek, we cannot do it, Harvard cannot do it, you really need a government behind, or ultra-rich companies, in the $1 trillion valuation to do this. But basically the number of GPUs you need and the energy that you need to actually power these things, these searches, is gigantic, but really gigantic. The other thing, two things I want to say before I move on to the consideration, to the ethical considerations, and then we discuss with Licia as the chief editor of the ICREA-ICCUB. Is two things. One is an anecdote. Actually, these LLMs, the most amazing innovation was BERT, which was the embedding. Licia and I have a really close friend that was the office mate of the guy that invented BERT. This guy that invented BERT was the actual nerd. He would be always on the computer. He would eat only fried chickens that was brought to him. Before he moved to Google, he was working at BBN in Boston, right? And he was asleep on a little couch that he had there, right? But our friend tells us he was a genius, like a complete genius. The other thing I wanted to say before we enter in these ethical considerations is that we do have a team of philosophers in Denario to actually verify what we are saying, right? We are not so naive as not to have experts on this subject, right? And we have actually talked a lot about the philosophical issues, implication of technology about that. So let me start the discussion with a simple test for you, right? Why did I put these plots? This picture, sorry. If I look at the picture above and I have a question, what is behind the heads? What will be the answer that most people will give me? A horse, right? And the reason for that will be that you're seeing a stable. So you are doing cosine similarity. You are doing the same as an LLM. You're using the context to infer that there's a horse. But if I ask you in the bottom, this is actually a house in London. What is behind the horse head? Some people may say, well, maybe it's a sculpture. Maybe there is nothing, maybe it's just a holder, right? Maybe it's a handle. Why? Because it's not very likely that you have a horse in the third floor of a house, right? So context here in your brain is actually very important at making this decision. So when people get outraged about LLMs, I like to remind them that you are using that all the time. I'm not claiming the brain works like a neural network. I don't think it does. I have no idea how human brain works. I have no idea. But I can tell you two things. We don't do back propagation. We don't go back into the ways to figure out the best. The brain doesn't do that. And the brain is connected in a very different way that neurons are connected in a neural network. So one thing we know is that the architecture of the brain is totally different and the algorithms are totally different. But somehow we seem to be doing it like that. So maybe, Licia, you want to start with the ethical consideration.
Yeah, so ethical consideration is more like, reflection on what we have here. And the first thing, and it is more for a conversation rather than me telling you the answer. The first consideration is, how would we define quality of research? So the thing that I get in mind is the following. The first N-body simulation, those of you that do N-body simulation will know, you would save every snapshot because it was very difficult to run the N-body simulation. So every snapshot for the patients. Now, you don't save all the snapshots because you can't rerun them. So you save what you need, you throw that because saving it, it's very expensive and running it is not that expensive. Is that the same? I mean, we get the papers, but we don't consider it as a paper. We don't just save it in the knowledge and in this repository that is indexed and everything, because it will take me very little to regenerate it, like rerunning an N-body simulation. Do we need to do this shift there? What is quality of research? What does it mean? If we see the paper and we know that it will now go through an editor, ICREA and whatever, because it will not be coded, do we call that research? Do we add it to the box of pristine new information? Is that really new information, given the fact that machine just took everything that was there, ran through it, as a result?
I can tell you a reaction that I've been having since the beginning. which is that I feel that you're talking in a very calculational, computational, simulational way of thinking. And yeah, I mean, machines can do lots of that, but I'm not sure they will come up with new ideas. Okay, that's a crucial point. I mean,
I think you're
if you give me,
I think you are totally right.
suppose I could do I could solve every equation, do every single simulation that you need to do everything power. It doesn't necessarily make me a better physicist.
No.
I feel that you're putting a lot of weight on that.
You make a perfect point, and let me just say something from our field of physics. Since the first one working in 20-dimensional black holes, when we result. Until Maxwell, the only thing we did in physics was fitting data. And it's trivial for a neural network to reproduce.
No, I disagree completely with that.
No, the only thing we did.
No, realizing that the apple is
Exactly.
It's a new idea that I'm not sure a machine will.
Yeah.
Was fitting data.
That is so relative.
The opposite.
Say one
You
thing.
can get that easily by making such things.
How?
Sorry?
And you say that people react in outrageous, outraged to this.
Because it is correct.
No, it's exactly the opposite.
And you don't have to build an instrument and cherry picking.
Okay, I'm gonna second.
But
So-
so take Aristotle, right? He had done that.
How
He had
many,
said all the outrageous things he said, right?
how many
Like
papers
about
we
four.
publish? How many of the papers that go through an editor and get published today really have original idea the way you define it?
But
Yeah, I think that's the point, right? We are flooded by papers that don't actually even produced by people that don't actually contribute significantly, right? So you need to have a measure of what is the delta that the paper contributes.
Yes.
And I can imagine actually you could come up with some ideas that you haven't seen.
Yes.
Because you don't have the full body in your brain of the knowledge that's out there.
Maybe a positive way is going to be like the best measure for garbage, no? Like in a way, like if you can differentiate from this, it will be size.
Yeah.
So I think that, I mean, to define quality of research, we're always making extrapolations to the future. Good research is research that's going to have lasting impact. That's say a basic definition. We don't know whether it's going to be like lasting impact. So then, I mean, we extrapolate and then we imagine that it's going to happen. But predicting that from the current situation, that's very difficult.
Yeah.
So that's your expression. What's quality of research?
Yeah, and what's impact? And what's impact? Because if it is citation,
Lasting impact is something. No. I mean lasting impact longer term than counting citations. We know lasting impact when you see.
a posteriori.
We don't need a precise definition. We know it when we see.
But a posteriori.
A posteriori, of course.
A posteriori, of
Because lasting means that you have to wait until when you have the perspectives to see that.
This cannot be a definition of good research because good research can be good research besides the impact because somebody didn't read. Because it is floods of information, somebody could not.
If it never has an impact, then it doesn't count.
It doesn't count, but it would be good research anyway. So
if eventually there are always hidden gems and like sleeping beauties and everything that you only recognize 20, 30, whatever years. Then most good research, even if it didn't have an impact at the time. But I think if it never, I mean, extrapolating to T equals 16, if it never, if it's never had any impact, then it does not.
But it's much easier to actually distinguish whether it's a good idea that will have lasting impact or not if you are in a high signal to noise environment. If you are in a low signal to noise environment, or when you have an avalanche of things like this being produced, where to produce it, it takes an hour, and then just to push it through the current system, just for an editor to look at it and a referee to look at it, it takes longer than producing it, then the whole system breaks.
Can I perhaps connect a little bit with the previous argument from Rafael and David as well? Using this system, then everybody, single person, will be able to produce papers, so you can easily recognize
one paper an hour,
It would be one person producing one paper, so it would be thousands of papers produced by thousands of people, But then the collaborative effort will mean something more at that point. And when you will see a paper where there are 3 authors, 4 authors, then at that point, you are kind of sure that it's not produced in that way. Because
Are you sure?
okay, let's say I'm not sure, but it gives more credit.
Authorship, it's a mess, and you know.
No, but what I want to say is that there will be a point where, since you can produce by yourself your own paper and everybody can do that, then the collaborative effort would be something different and maybe more valued.
How do you
That's
know that a
right.
paper is a collaborative effort? When you
Well,
can write the paper and put whoever you want as an author,
Pointed
right?
out that you meet the people. It was pointed out that still editors can do the job and say, well, there is.
I'm saying the editor will not be able to do the job. That's my point. But
I want to dwell on this because I don't understand why we're talking about people producing papers. You could just ask, automatize this and tell Denario, look at the entire internet, find everything that people solve and go and write papers about everything. That's it. We don't have to do science anymore. He will find all the questions that have ever been posed and he will try to answer them and write all the papers. So why are we talking about people producing papers?
So what I'm saying is the following: the current system that we had is at the breaking point, and this will swamp the current system that we have, which is what we've put in place in centuries to actually define this very high signal to noise, new ideas repository that is high quality, you can search, you can look. Now, so that's on this end, and on this end you are the input. If the input is already high signal to noise, then you can produce it and you get to this pristine bucket.
But why does the input have to be provided by people?
No, it doesn't have to be provided by whoever you want. It doesn't have to be provided by people. It can be provided to whoever you want. But you say that whatever this produces is not this new and original idea, which is what we want on this, on the bucket of new and original ideas that stand the best of time.
But I think.
So let me, can I comment as one of the, I'll take precedence out of it. So coming back to your point, what Denario and all LLMs currently do is the following. If this is the body of language, right? The body of knowledge, of everything, right? That you can access, right? It will basically interpolate here with very little extrapolation because you are forcing it to cosine similarity as Pedro explained, right? Now, if you want to generate new knowledge and new ideas, you have to extrapolate, okay? Now, this will be very bad at extrapolating, but so are humans.
That's why humans do it, to come up with new ideas.
Yeah.
No, I can force the LLM to extrapolate if I want to, but then
it will hallucinate.
It will hallucinate, exactly. And the number of bad ideas is going to be so gigantic that to pick up the good one, so we don't have the hardware to do that. The question is, if you want me to do that, I will have to extrapolate. I will have to ask the system to extrapolate, right? It will generate so much extrapolation that I cannot handle it. I simply cannot handle it.
And why are you producing something that is going to be very good at producing routine, correct, but probably not too terribly lasting quality?
Because I disagree with that, because
it's a tool.
Maybe it's just a feeling. You may have knowledge, you have policy. You fix it.
This is a tool. So the collaboration produces as a tool to help researchers to automatize the thing that we find difficult because there is a lot of noise and little signal, and doing the literature search and fighting with the Python code and producing a nice picture is well all our overhead goes, and we want to think about new ideas. But the other end of the coin is that if we look at the current scientific production, 90% of the paper that we publish are not, or even more, are not this new and original idea thinking out of the box.
To me, this is going to be worse than that percentage.
What percentage?
You say 90% currently is perhaps correct. There are no mistakes in the algorithm.
Still new, specific thing hasn't been published.
It's a small variation, but now you tell me, in the morning, while I'm having coffee, I'm going to be able to produce 70 papers that are correct in the sense that there are mistakes, and none of them will have any
Yeah.
relevant new idea. So you are going to work on the percentage of correct papers that don't bring much to
But
the.
this will break the system because right now, as an editor, you invest, say, an hour in a paper and the referee invests half a day in a paper. This is epsilon compared to your effort in producing the paper in the first place. But now if you can produce 24 papers a day, and then it takes you 2 days to review each of these papers to figure out whether it's a paper or not, you break the system.
So is the hope that you are going to break the system?
Whether the hope or not, this thing is out there and it's gonna be used. An archive is flooded and my journal is flooded.
I think that it's gonna become, the review system is gonna have to become the same thing.
Like a Denario review.
Yeah, I mean, I'm sorry, but you're right. What you're saying, it's gonna be filled with papers, it's gonna be like.
Nothing upon that, but you want to use, I mean, you want to use the language model to actually figure out confined popularity, right? To figure out where the deltas are.
Exactly. So one thing I want to say is that I'm not trying to sell this to anybody, right? I mean, this was just a present. But I'm just trying to present a tool that we can build that for us has been extremely useful at 20%. So for a very mathematical problem, Pedro created a prompt that actually produced extremely nice results. But just, it's not, but I want to add another comment, right? Hinton and all these people, these neural networks algorithms are from the 40s, 40s. And they were considered absolute crackpot, like nobody thought this had any sense whatsoever. It took actually the advent of hardware to actually be able to do this. Basically, deep layers, so you can do nonlinearity, right? This is the key here. And of course, you know the story. They won the Nobel Prizes. They dropped out. Kasavis won the Nobel Prize in chemistry for solving a problem that nobody could solve. Protein folding was a completely hopeless work, right? So you can decide, do you want to use it as a tool to do research, or you want to go back to your method? It's your choice. But I will tell you what my very good friend Uros Seljak says when he talks about this. This is coming, this is happening. Ignore it at your own risk, like climate change. You can decide what you want to do, but
I'm aware that it's 11:35 and we book an hour only, so people may have other things to do. Feel free to leave and feel free to stay and discuss if you want.
I just have one point because I think I'm more in agreement with you than you may think. You just identified the point. There's one thing that we can still do better than these systems. We should focus on that. Eventually machines will catch up and they will become better than us at extrapolating. I think that will happen.
Well, it's better. We're exponentially better at extrapolating. We're exponential for whatever reason. I don't know which one.
Yes, but eventually, I'm not a denier saying that this will never happen. There will always be humans. No, I don't think that will happen. I think that eventually they will catch up. But for the time being, this is not happening. So let's focus on that.
Yeah, so I agree. So that's actually you nailed it on the head. That's the idea of Denario.
But this has consequences. This has consequences. Plagiarism. This is because this large language model recook whatever it's out there, and there is a dimension of plagiarism. The way we treat plagiarism right now is not equipped for this kind of things, and some measures are coming down the pipeline. I'm going to tell you what the measures are. As we know now, they are not public yet. Implication for scientific training and education. Maybe we don't have to train our students to debug their Python code. Maybe we have to train them in writing prompts for large language model. I don't know. We don't have to train them to actually learn how to write in English, because maybe you just put some broken English sentence and then you give it to one of these things and it makes it look like the way you want, like Shakespeare or like Feynman or like whatever, right? Homogenization towards what? This kind of thing will produce a lot of stuff, but is a rehash of what's already there because it doesn't extrapolate. So you're going to have an homogenization towards something. Is that what we want? Is that what we need? It's coming anyway. By the way right now, most of these papers milled done by AI are being used for, because it's much cheaper than doing like that, they are used for citation rings. That is, you want to be cited. So what do? you by AI create a lot of papers written by other people. You tell them, you want a paper, I give you a paper. Another one, I don't need to be an author. That's IQ. And there's no way to find out this unless you do it statistically. Because you see the statistically paper that are borderline in quality, that have bits of pieces that looks like they're written by the AI, you're not completely sure because you can humanize your AI text, whatever. They all point to the same citation. And some of those authors, you have no trace of what they are. Orchid that overlap, strange email of, alumni here and alumni there that are not email. I mean, you see things like that. Now they're being used for citations, as far as we can see. Surely they're being used to beef up your CV, because I've seen that. Access. This is expensive to run. Environmental concerns. This is
undemocratic.
It's undemocratic. Well, it's democratic in some way, because when I have to write a complex idea in English, and English is not my first language, it's more difficult for me than somebody that was educated in English since that person started to write. And so this is actually democratic, because now I can express myself in English as efficiently as a mother tongue. So for proposal writing, for paper writing, for presentation, it's democratization. But then there is another environmental concern. That's really malicious use. We'll discuss it. Authorship. Now, who's the author? Denario can be an author? No. The author needs to be a human, because you need to take responsibility, and machine can't take responsibility. So it cannot be an author.
But when you write a paper using heavily mathematical, you're still the author. I don't see the difference. This is another tool, more sophisticated.
Yeah. So, but you have to take responsibility. So many of these.
Of course.
As far as
What about this?
can you use mathematical to write a proof of a theorem?
No, but if you do a simulation that nobody can reproduce without a machine, right? And there's an answer, and you didn't know the answer before, you're still the author, right? But it was a machine that did it.
That's fine.
And the machine produced the plots, no? You plotted.
No, I understand. I think the border is okay. I can ask. Can you prove this theorem? That
No, you can't.
So in mathematics,
It doesn't do it.
So when
You can ask, but it's very bad.
So there are, but there are tools in math that are used to prove theorems, and there was a big
Mathematical proving, this comes from Microsoft, who was actually to develop a tool that was going to automate codes, right? And then the mathematicians realized that they could use that to check proofs, right? Because these proofs are like 200 pages long, right? And people spend years of their life, trying to prove that this thing is correct. So this is something that's actively being chased, as you say,
But mathematics is one of the fields that has, by the way, the worst problem, not necessarily AI, but with a sort of low quality papers, and this is mathematics, it's in trouble. There was an archive paper exactly about that, where the Mathematical Society decided to take a stand and say what we need to do, because this is yet another things that allow this malicious use just explode.
I have a comment, which I feel that many of the things that you present as a problem, of course, will be exacerbated by this. But conceptually speaking, they are exactly the same problems. And for example, this interpolating problem, papers. I mean, even people who manage to write a paper that will be still relevant in 50 years, which are very few, may write 50 papers and only one of them. So should we not publish all the other 49, and for the rest of the humans not publish anything at all they ever write? Because this seems like a problem, but it's something that is already happening. And these citations, why is that a problem? I mean, would we ever hire someone based on the fact that they have many citations?
Yes.
Okay, so let me speak for myself. So, well, I don't.
At least in our fields,
No, if you talk to someone for half an hour, you get much more information about the quality of the person than anything else.
True. But then exactly.
No, but then we can criticize aspects of the theoretical system that have nothing, absolutely nothing to do with this. It's already not working for other reasons.
They have, because the system of incentive that we have in place right now favors the racketing of scientific publishing where if you publish, you pay. If you pay, somebody makes money regardless of what you publish.
You understand? You are giving a word the old-fashioned way, attribute ABS, or publish 15 papers a day. Perhaps that good student that you would hire would never make it. Because it will get lost.
Yeah.
I wanted to go to the question of referee. That seems very important here. And one interesting thing is that the archive is already like 30 years old. But then we continue to have the most reputable journals, right? Are for historical reasons the ones we have on the board. And the refereeing system hasn't changed very much. So one thing I wonder is, why don't we do the referee archive itself, right? People put the papers there.
I know. Yeah.
Then you have to send them to a journal and do all this refereeing.
I can explain. It's not a system that scales. So archive has moderators, but the moderators just check the paper for the most egregious idiotic things.
Yes.
To archive costs 10 euros per paper.
Yes.
A journal needs to do the refereeing, the quality control, etc., and it costs at least 800 per paper. The whole system, etc. What happened? You just say, let's just do crowd refereeing. Just put it on the archive and see what the crowd refereeing does. What's gonna happen? Everybody wants to referee only the paper that they find interesting or they find easy. And so one paper gets referee and 100 remains they are not referee.
But it's a matter of funding. And the question is the funds go to the journals, not to the archive. And maybe this should change, because to me the logical thing is that archive would referee. And it needs funding for that.
Oh, yes. And the system doesn't scale because the journal management systems, it's complicated. Because things need to go back and forth between editor, referees, etc. And the archive is much simpler. Yet the archive system, it's taken a lot of millions and a lot of people to just keep it running. Yeah. If you also add on top of that all the back and forth of the refereeing and the editing,
remember that there's a multi-American-based effort, right? And the current situation is so bad.
Politically,
But this debate has been going on for 30 years, at least, and haven't come up with a better system.
Yeah.
So I'm not sure that we're going to.
Yeah.
But for example, archive has a system that in order to put the paper there, you need to sign up. Somebody needs to
be endorsed.
Right? Yeah. You need to be endorsed.
The endorsement is going to change.
That
because it's not sufficient.
Right.
It's going to change.
That's already one field. Not everybody can put a junk there. And then you have to figure out.
There's a lot of junk there.
Right? People who put a lot of junk are kicked out.
There is already. But it requires time and effort to actually follow that up. And resources.
Yeah.
And the system
with the different climate of science funding in the US, it will go the direction you are pointing. Yeah, money. That's what I mean. Money.
No, it's the publishing system. The publishing system makes more money than the music system or the film system. So the industry. So do you think you're really going to go against the entire music industry in terms of
there's no
volume of money?
Right? That build up and it's difficult to get rid of.
It's very difficult to get rid of it. So anyway, since I'm conscious of the time, let me announce some countermeasures that are being considered. In paper, you will have to declare how AI was used. Because now we all will end up using AI, the way we use Mathematica, the way we use the plotting routine, the way we use Grammarly. But it would have to be declared. And only specific use will be allowed. So then you can't write in your broken English and ask AI to write it better for you, but you can't significantly expand or significantly reduce what you actually write, with few exceptions where, say, you want to submit something that is not in English, and then you present a translation and the translation is completely done by the AI. The penalty may include being banned from publishing for a period or forever, because this is a game that if everybody play nice and few people don't play nice, then it's extremely unfair.
Sorry, you're saying then that using Denario would be banned?
No, Denario is not banned. So you can use Denario as a tool for your research.
You're writing a paper with Denario. That was the goal. That's what I asked you at the very beginning.
Yeah.
and you're submitting it and you fail at all of this.
So don't submit it.
So then why are you wasting energy and efforts to write the paper? I don't understand.
Because I want to explore an idea.
And it costs a lot of resources. This shit costs a lot of climate change if you want, right? Everybody's trying to say,
It's possible to do it, somebody will do it. The current system that we have can't handle that. So the current system tried to put some way to save itself. We can agree that maybe the system should not save itself. Maybe we should keep the system up and running with the Scotch tape until we have a new system in place. We're just discussing.
Let me answer your question, because we wrote a paper with Denario, and of course, immediately you open the floodgates, right? So what have we done with the paper Pedro and I wrote? There's a very famous conference going on now at not the crackpot university, it's called Stanford University, where they are taking papers written by AI, right? And you declare how much of AI you use. We sent a paper that was 100% produced by Denario, and we are there in the running for the. You know that in computer science, the conference is what it counts, right? So there's going to be roads where you can actually write a paper in Denario and publish it. I mean, we are there. So
but for a different purpose.
It's a different purpose. It's a different field, right? But all that we learned from Denario in this particular case, we have implemented it in a paper. Is that we're looking at it in more detail. But basically, when we asked Denario about this particular problem, it's something unrelated. It is we wanted to classify the latent space of solution of Navier-Stokes, of related Navier-Stokes, and he came up with a brilliant idea. And this is something that we are writing up in 3 weeks with our mathematics colleagues in Zurich at the ETH, right? So we are writing a paper. We are not just pressing the button and sending the paper.
I think that this has become really schizophrenic right now, because you started by saying things like, this is coming, ignore it at your own risk,
yes,
like climate change. And now you're saying, but only use it up to this point, even if it produces good science. So I don't understand. It's like saying you can use Mathematica, but only for Taylor expansions. You cannot use it.
I still don't know the method.
But I think that's correct. I wouldn't use them this solve for solving.
So we are not the emperor of the world deciding how the world should work. What I'm just saying is, this is a tool that is out there, and the authors say you should use this as a tool, not to actually produce paper and submit the papers for you. However, once the tool is there, it will be used. Since the tool is there, it will be used. It's obvious that it's going to swamp the current system and it's going to make the current system break. The current system knows that. And so the current system is trying to protect itself. And how does the current system will protect itself? Will protect itself by saying, oh my gosh, we can't use AI to produce papers. The AI cannot be an author. The current system assumes that the author is a human. Assume responsibility, authorship has got a specific legal meaning, don't use it. That is not a scientific thing. Now, we may disagree, we may say that is a scientific thing. But the current system will, at the moment, the first reaction will be.
Well, unfortunately, we had to take a daughter to the doctor. But in the time we were talking, Denario wrote a paper about hidden symmetries in the Hordesky-Lagrangian. This is an interesting point because, you know, the only one that we know doesn't produce gauge is the Galilean one. So this is the thing. So
when we look at the paper, so there is an introduction.
There is the typical flaw of the Denario that Paco was pointing out, that the modular data, it has the problem with the percentage bar. I'm seeing at the end of the
yes, I know.
It puts the and without the dash. I don't. It's incredible that it can do so much complex things and fail at this specific end of the abstract. Yeah. It's because there is a percentage and it forgets to put the dash. You can put it by hand.
I can put it by hand.
That's it.
I can actually.
So anyway, while you put it by hand, let me just say the thing. One thing, the one that R&D will understand what I mean. I want the AI to do what the OR doesn't do. I don't want the AI to do my papers and my job.
No, I disagree completely. So I guess tonight.
I
guess tonight.
Different messages being given constantly.
the things that are boring and that we don't want to do, like, expense report, claiming from the trip, paying reimbursement from the trip.
No, I disagree completely. And the reason for having different messages was to have an open forum about this. I guess I will sleep on the sofa tonight.
Okay, so the paper.
Okay, so this is the paper, right? It is yeah. I will share it with people, especially the ones of you that do theoretical physics and related things, or whoever wants to.
So let me look at the paper like if I was an archive moderator and see whether it would go through archive moderation. Can you skip through it?
As a methods.
This will probably go through archive moderation.
It has fixing the typos, right? It has a plot with the results.
One plot became
and results and conclusions. I mean, I didn't ask it to generate the bibliography, the references, because it takes more time, right? I just told it don't bother about it because it was a test, but.
So this will go through moderation, and this will be submitted to a journal, and then the editor would have to take the time to actually read, find the referee. Maybe the referee will say, well, the paper is correct, maybe there's not much new, whatever, but it took an hour to generate it, and it will take more than an hour for the system to actually just push it through the system. So this is going to break the system.
Some parts of the system, yes.
Let's see what that.
Okay, I mean, happy to continue the discussion offline. We have to set up. We are here, and especially Pedro has been very much hands-on with the system and the problem. So Pedro is a great reference for anybody to talk to and discuss these things. So thank you for coming.